Now once you know how to derive y equals ln of x, you can use that to derive a lot of other functions involving the natural logarithm. So let's start with y equals ln of 4x. That's a very easy application. What you do is use the chain rule, call this u, and then y equals ln of u. So then dy dx is dy du times du dx. dy du is just the derivative of ln of u, and that's 1 over u. And du dx is just the derivative of 4x, which is just 4. So that's 4 over u. And if you remember that u was 4x, that's just 4 over 4x. You cancel out the 4's to get 1 over x. So cool thing. Doesn't matter what you're multiplying x by here. As a general rule, the derivative of ln of some constant times x is just 1 over x again, as long as x and the constant are positive. Now b. To begin that one, you have to use the product rule. So the product rule will say that dy dx is the derivative of the first so the derivative of x times ln x plus x, the derivative of ln x. So that's 1 times ln x plus x times 1 over x. So that's ln x plus x over x, which is just 1 as long as x is different than 0. So just write that as a note right here, that x needs to be positive as a note as well. And that is the answer for our problem. Now here is the next one. C, if I split that up so there's no confusion. C is asking, or using the function y equals ln of absolute value of secant x. Now, from the first example, whether you multiply secant by 1 or by -1, that's not going to make a difference in the derivative of the ln of secant. So this absolute value doesn't really make a difference. As long as secant is not equal to 0, we can pretend that this absolute value is not there. So it's just going to be dy dx will be 1 over secant x, and you can keep the absolute value here, times the derivative of secant x. It's 1 over absolute value secant x. And the derivative of the secant, I don't remember that one, but I do believe it's secant times tangent. If I don't remember, if I'm wrong, we can check, but I believe this is secant times tangent. So this is what we have. The derivative of the inside. Now for D, finally, y equals ln of x squared over x squared. How cool is that? I can use both the chain rule or the quotient rule. I'll use both, I guess. So I'll say x squared equals u, and then y is ln of u over u. So dy dx will be dy du, and on that first one I use the quotient rule. Then du dx, I just use the power rule. So dy du, that will be quotient rule here. So that is the derivative of the first, 1 over u, times the second minus the first times the derivative of the second. So the derivative of u is 1, because we're deriving it with respect to u. All that divided by the bottom squared, so u squared. So now that's 1 minus ln of u over u squared. That's only this first term. Now I still have to include du dx, and since u is x squared, that's 2x. So then that goes as 2x. And I can continue my calculation by replacing back what u was. So u was x squared, so this is ln of x squared over x squared times 2x. So that will then be, the bottom will be x to the 4th. With that 2, and with that x that I can cancel, that will be 2 minus 2 ln x squared. Canceling the x to the 4th with the x to the first at the bottom, that's x cubed. And that is my final answer.